And now it's given that we know, so we know that the set V1, V2, V3 is linearly independent set, is linearly independent. Then by definition, then we know that there exists, so then we know that C1 times V1 plus C2 times V2 plus C3 times V3 equals 0 implies that all C coefficients are 0, right? By definition. So by definition, okay. Now I will take this and apply to the transformation to both sides. Okay, so I'm going to write it like this. So let me write it here. So then apply t to both sides, which means this. So I'm just basically going to write this. So we know that t c1 v1 plus c2 v2 c3 v3 will also equal to 0 because t of 0 goes to 0, right? So now since t is linear, then using the property 1, so then it will preserve, t will preserve under addition, right? So then I'll write it like this. It will be t c1 v1 plus t c2 v2 plus t c3 v3, and this will equal to 0. And then by the second property, it's preserved also under scalar multiplication. So you can just put the c1 outside, c1 plus c2 2 plus c3 3 equals 0. But I know that from my assumption, right, from what's given, I know that all c's are 0. So this implies that c1 are 0, right? If all c's, so if you have a combination that is 0, right, and this combination can only be 0 whenever all the c's are 0, then that means your vectors are linearly independent, and those vectors are tv1, tv2, tv3. So then this means that you have this set which is linearly independent. And the reason is you found that all the coefficients are 0 when you form a linear combination that is 0, right? So then this is